The next thing we're going to work on is something called the difference quotient. It's kind of this random thing thrown in a random spot. The only reason I can think of it's here is because we do this thing of f at x plus h, so we can say that it's something to do with a function. And really it is a bit of a description of a function. So what it is that we are going to be finding slopes of graphs that aren't straight lines. So we know that the slope of a straight line is the rate of change between any 2 points, where slope is equal to y2 minus y1 over x2 minus x1. The difference quotient is a measure of the average rate of change, which is the slope, over an interval. So the graph doesn't necessarily have to be straight. We're just making it straight in a way. So what we could do is we could take this non-linear graph, so like this curved graph here, and we could say, hey, I want to find the average rate of change between these 2 points on the curve. So we could make a straight line between those 2 points called the secant line and find the slope of it. And so what it would be is that you have a point x and then another point here that has a space of h between it. So this point here would be x plus whatever that distance h is. So we have the x value of x and an x value of x plus h. And then our y values would be whatever our function is when we put in x, or whatever the value of our function is when we put in x plus h. So if I then use the slope formula and said it's the average rate of change between the y values over the x values, it'd be the function at x plus h minus f of x, right, over x plus h minus x, which if I simplified it, I would get f at x plus h minus f of x all over h, and we call it the difference quotient. Okay, and this is what we're going to be evaluating. So let's start with a linear graph. So if I have a function, f of x is equal to 3x plus 7, and I ask you to find the difference quotient, this is going to be finding the average rate of change between any 2 points on the graph. What do we expect it to be? Well, if you remember back to y equals, I don't like y's and 4's, y equals mx plus b. M is the slope. So I'm expecting my slope to come out as 3 because this graph doesn't change. This is a linear graph. So no matter which 2 points I find the slope between, it's always going to be 3. So let's just check to make sure that the difference quotient works. Okay, we're proving to ourselves that this is going to do what we want it to do. So the difference quotient, which you can find on your formula sheet, right? This is not something you have to memorize or look up, is f at x plus h minus f of x all divided by h. So what I like to do is I like to find f at x plus h on the side. So if I was going to find f at x plus h, because if I try to do it within here, it's going to make I have to write so much extra every single time that it's just easier if I do it over here. So the value of my function when I put x plus h in is that I'm replacing the x with x plus h. And then I'm going to distribute. So I get 3x plus 3h plus 7. This is my value of my function when x is x plus h. So I'm going to put that in here. I've got 3x plus 3h plus 7. And I'm going to take away the original function, which is 3x plus 7, and I'm going to divide it by h. All right, let's keep simplifying. So I've got 3x plus 3h plus 7, and then I'm going to distribute the minus sign through. So I've got minus 3x minus 7 all over h. And then I'm going to look for anything I can simplify. So 3x minus 3x is gone, 7 minus 7 is gone. I'm left with 3h over h. And for this graph, I get a constant slope of 3 because it's a constant line. It is a line. It's what I expect. Okay. But let's do another one that's not a line. So let's look at a graph like y equals, or f of x is equal to x squared minus 4. So you'll notice that this one, there is no straightness to this graph, right? There's nowhere that the graph is going to be constant or have a constant slope. So what we're going to do is use the difference quotient so that we could then find the slope between any 2 points. So the first thing we do is write out the difference quotient. F of x plus h minus f of x all over h. That is our difference quotient. It never changes. Then always, I like to over on the side find f at x plus h. So my function is x squared plus 4. So in for the x, I'm going to put x plus h all squared minus 4, and then I'm going to simplify. Don't forget x plus h all squared means x plus h times x plus h minus 4. So I'm going to distribute. I get x times x is x squared. x times h is xh. H times x, I'm going to write xh, although alphabetically I probably should have written the other way. And then h times h is h squared minus 4. So now this is what I'm going to put in for the value of my function at x plus h. So up here, I've got x squared plus xh, sorry, there's two xh's, plus h squared, I didn't finish simplifying, minus 4, minus x squared minus 4, all over h. I'm just going to finish this off. X squared plus 2xh plus h squared minus 4. Okay, now I'm going to simplify. So I'm going to distribute that minus sign through. I get x squared plus 2xh plus h squared minus 4 minus x squared plus 4 all over h. Whew. All right. It's like a test of your organization and your ability to write clearly and neatly, right? It's always one of those things. Like, no one has a problem with any of the skills in here. What we have problems with is integers. We always mess up. So now we're looking to see if anything simplifies, and something always should. So you'll notice in this one, the x squared minus the x squared, the negative 4 plus the 4 goes away, and the terms that are left are the ones that have the h's in them here. So I've got 2xh plus h squared all divided by h. Now, can I simplify further? So you can do this two ways. You could think of it as 2xh divided by h plus h squared divided by h, right? So when you have a binomial numerator and you're dividing by a monomial, both of the terms in the numerator have to be divided by h. Or I could simplify by factoring. So I could greatest common factor out in h to be left with 2x plus h all over h. So now the h's will simplify, and I'm left with 2x plus h. Sweet. This means nothing, right? I mean, maybe it means something to you, but for me right now, I'm like, great, what did I get? And for a long time, I was just like, whatever, it's fine. And I started thinking, I'm like, I should probably figure this out. So what this means is that this equation, or this expression that I found right here, 2x plus h, this will find the average rate of change between any 2 points on this curved graph. So I wrote a note here to say, check with a slope between negative 2, 0, and 2, 0. So if I was to find the slope between these 2 points, right, I've got a flat line. I know that the slope of a horizontal line is 0. So let's see if we can use the difference quotient to come up with the slope of 0 between these 2 points. So how am I going to do this? So I'm going to find a space. I'm going to check. I'm going to check the space between negative 2, 0 and 2, 0, or the line between. So how do I do it? Well, my x value is going to be the first x value I start with. So my x value is negative 2. Then I have to look at the distance between these 2 points as my h. So my h is 4, because between negative 2 and 2 is 4. So I'm going to say h is 4. Then I'm going to use my difference quotient, I'm going to use my dq, to see if my slope turns out to be 0. Well, I've got 2 times negative 2 plus 4, which gives me negative 4 plus 4, which is 0. And I got the slope I was expecting. So that's what this does. If you do the difference quotient for a function, that new expression you come up with will find the average rate of change between any 2 points on your graph. All right, so there's a quick check. I put 55 as a good challenge. You know, it's never a bad idea to start practicing rational expressions, so things where you have fractions within fractions. So the more you practice it now, the easier it'll be when we do it later. All right, good luck.